Good morning, students. In the last class, we were doing about the congruency of the triangle. We did a few examples. We started with exercise 5.1. Let's go to the next exercise. In an isosceles triangle ABC, this exercise 5.2. Exercise 5.2. In an isosceles triangle ABC, with AB is equal to AC, the bisectors of angle B and angle C intersect each other at O. Join OA to O, show that OB is equal to OC. And side AO bisects angle A. See, for this, they have not given a diagram. Based on this information, we have to draw a diagram. The first one they have given as in an isosceles triangle ABC. Start with an isosceles triangle ABC. A, B, C. These two sides are equal. If these two sides are equal, these angles are also equal. What is the property of an isosceles triangle? Opposite angles, opposite sides are equal. Then the bisectors of angle B and C. The bisector means this one. See, whenever equal angle this is, let's assume this is 60. If it's bisect means this angle should be equal to this angle. Okay? And here the bisectors of angle B and C meet at a point O. Meet, intersect, join A to O. These two has to be joined. Now in this case, OB is equal to OC. OB is equal to OC. That's the first thing you have to prove. Second one is AO bisects angle A. That means these two. BAO. BAO is equal to CAO. Let's assume this is angle 1, this is angle 2. So we have to prove angle 1 is equal to angle 2. Solution. Now OB is equal to OC we have to prove. Which is OB? OB is equal to OC. Done. Now if I want to prove these two, take these two triangles. This is one triangle, this is two triangles. Anyways, we know these triangles are equal. These two sides are equal. Correct? And this will be the common side. Then, can we do that? Or, this is one option. Or else you can draw a perpendicular line. First, let's take these two triangles and see. Okay? This is A. And this is B. And this is O. Here A, C and O. Then AO is common, right? See, this is common. And then ABO. ABO. This angle equal to ACO. I got these two. Now next one. What are the information you have in this check first? I have one as this is side, this angle, and I know AB also, right? Even this equal to this. Because isosceles, right? So angle side, we don't have any such criteria. Now this is common. So in this, we cannot do anything. We cannot prove. So what we can do here is, do a construction. Draw OD perpendicular to BC. Okay? In triangle OBD and triangle OCD. Draw OD perpendicular to BC. Now whenever it is a perpendicular, this becomes 90 degree. Now if you see these two triangles now, I know that OBD is equal to OCD. Why? Isosceles property. And then angle D is equal to angle D, because this angle D belongs to both the triangles. 90 degree. Again this OD side belongs to both the triangle. OD is equal to OD common. Therefore, I can conclude that OBD is congruent to triangle OCD. Now, if these two are congruent, can I tell OB is equal to OC? OB is equal to OC. CB, C. This is done, right? Now, what is the next part we have to do? We have to do with these two angles. Now, how do we start with the next? Take AOB in triangle AOB and triangle AOC. These two are the two triangles. AB is equal to AC. Why? Because isosceles, which is given in the question itself. Next, OB is equal to OC. Why? Because we have already proved. Next, AO is common. So what kind of a criteria is this? This is side, side, side. So it is SSS criteria. Hence, both the triangles are congruent. If both the triangles are congruent, angle 1 is equal to angle 2, which is BAO is equal to CAO. This is how you prove it. Okay, I would like to tell you that until unless you don't practice, you do not write, you will not understand. The day when you see this problems, you have to write. Only seeing does not help. Practice. Mathematics can be learned only when you practice. Remember that. If you do not write, you will not understand. Now the next one. Okay, second, I want you to try. ABC is an isosceles triangle in which altitudes. What is the meaning of altitude? Altitude is nothing but the height. And height is always a straight. When I tell straight, it is always 90 degrees straight. Remember that. Now they are talking about a triangle and its altitudes. A, B, C, E, F. ABC is an isosceles triangle. The moment whenever they tell about the isosceles, no, AB is equal to AC. Done? It is given. Next one. ABC is an isosceles triangle in which altitudes B, E, and CF are drawn to equal sides AC and AB. See, they have already mentioned equal sides, which is AC and AB. Show that these altitudes are equal. Now, which is the altitude here? Altitude is B and CF. So, what do we have to prove? To prove BE is equal to CF. How do we prove? See, this is 90 degrees, right? Now let's try to take in this triangle. Okay. Always remember, when they tell altitude, it is the height. Okay, height is the altitude. Now BE, I was right here, BE, 90 degree. Again, CF, 90 degree. See here we have 90 degree, no? So I have written here ECF. Now this is A, this is A. Let's check. Both are 90 degree. I can write E as equal to F. Now AB is equal to AC. Where is AB? AB is equal to AC. Then, now here, if you see this angle, this is common angle for the pole. Can I write angle A is equal to angle A? Common. Which criteria is this? This is angle, sine. Therefore, as per angle, sine, triangle BEA is congruent to triangle CFA. Once when two triangles are congruent, as I told about the corresponding parts, BE is equal to CF. This is what they are asking. This is how you prove. Now the next one, it's almost similar, I guess. ABC is a triangle in which altitudes B and CF, two sides AC and AB are equal. Okay, this is little tricky. Understanding the question makes lot of difference. A, B, C. Again, they are telling this is one altitude, this is one altitude. Okay. ABC is a triangle in which BE and CF, two sides AC and AB are equal. That means this is an altitude which is equal. This is an altitude which is equal. What do we have to prove here? Show that ABE is congruent to ACF. ABE. Let's draw it separately and see what is the information we have. A, B, ABE and ACF. AC. This is 90 degree. 90, right? AB. ABE. Now these two are 90 degrees, right? And this is common angle. And then they are telling this side is also equal. See, we have angle, side. Angle, side. Okay? Write all the steps as it is. In triangle AEB and AFC. Angle A is equal to angle A, angle B is equal to angle E. What is the reason? This is common, this is 90. And then BE is equal to FC. This is given. This is given. Angle, side. Therefore, triangle ABE is congruent to AFC. Once when these two are congruent, we can directly tell that AB is equal to AC. If AB is equal to AC, what kind of a triangle is that? It has to be an isosceles triangle. That is what the second part they are asking. AB and prove that AB is equal to AC. Hence it is an isosceles triangle. Okay. Now I want you to check on this one, and again I want everyone to practice, understand. If you have any doubts on this, we will need a clarification for the interactive